right. Hey, I see a couple people on here already. Let me try to organize myself and see if this helps at all. Maybe we can get a little bit closer to some things here. All right. If you're in and you want to say hi in chat, you can say hi in chat. Love to know who's in here. And also, I guess what I'd like to know is, can you see that paper okay? I don't know, where's this glare? Let me see here. All right. Let's see if I can get rid of that glare. Well, that didn't help. All right. Well, here we go. All right, still hoping somebody will say hi in chat. We are going to be talking today about a couple things. You know, I appreciate everybody who filled out that question on Google Classroom and responded with what we wanted to make sure that we talked about today. Mrs. Wenmaker and I, hey Max, Mrs. Wenmaker and I will be alternating days this week, and you can join either of our, any class can join either of our live streams and go ahead and ask questions in the chat. You can reach out to us ahead of time via Google Classroom or email or anything else like that, and we'll make sure that we, hi Caleb, that we answer all of those questions. So I have some things today that we're going to be talking about. Let me just kind of lay it out. As you're coming in, please say hi. I would love to see who is watching this. So we're going to talk about just some definitions of like the arcs and the chords and everything else. Tangents, that kind of thing. We'll focus a little bit on 12.3, that section about inscribed angles and such, okay? Hi, Colette. Hi, Caleb. And as always, if there's anything you want, just throw it in the chats right away, okay? Hi, Sunny. Oh, man, I miss you guys. Happy Ticket Tuesday, by the way. You guys are going to have to remember your ticket numbers, and we'll take care of all that when things are back to normal here. Hi Billy, glad you guys are here. Thanks. I'm so happy so many people can join. I hope you're all doing well. For me, I'm doing fine. I'm getting a little stir crazy just being in the house all day, every day. I'm sure I'm not the only one like that. Cool. So I will get started. I'm going to quickly go over the lesson quiz from Unit 12.3, okay, the one that was due yesterday. Most people did really well, but there were some questions on it, so I figured, hey, maybe as we're going over the units, the topics from 12.3, we can just kind of go over that stuff. So here was the first question. If you can't read it very well, comment, because in my eyes, it's all backwards and everything else, and I will try to arrange the camera so you can see it a little bit better. So we have our circle, center is somewhere here, it doesn't really matter. And we have this intercepted arc. So this guy right here is 76 degrees. And once we know that arc is 76 degrees, hi Matt Cole, then we know any inscribed angle will have half of that angle measurement. Okay, an inscribed angle is an angle whose vertex is on the circle. So if we have an inscribed angle, no matter where it is, the vertex is on the circle. So that makes that guy an inscribed angle. So in this case, angle X then would just have to be half of 76 degrees or 38 degrees. Okay? And similarly, if we have our angle, let me get a different color here. If we have this angle that's 45 degrees, well, now that angle has to be half of the inscribed arc, or half of the intercepted arc, pardon me, half of the intercepted arc. So this arc B that is intercepted has to be twice as much as 45, and that guy ended up being 90 degrees. Okay, so that was our first problem about inscribed angles. The biggest thing to remember about inscribed angles is that the inscribed angles measure is half the measure of an intercepted arc. All right, so tried to prepare this guy. This next thing is something we haven't talked about in a video. So right now what we have is we have a tangent line, and this point S is what's called the point of tangency, because your tangent line only intersects the circle exactly one point. And it intersects the circle in such a way that that radius would be perpendicular to the tangent line at the point of tangency. All right, so now we're told that the measure of this arc SVU. So why did we name an arc with 3 letters? Well, you know that if we had just this chord, SU, a chord is a line segment whose endpoints are on the circle. If we had this chord SU, it actually intercepts 2 different arcs, one of which is the smaller one, which we'll call a minor arc. A minor arc is an arc whose measure is less than 180 degrees. And a major arc is an arc whose measurement is greater than 180 degrees. Okay, so now is the time in the comments. Hey, Professor Blake, now is the time in the comments. What do we call an arc whose measure is exactly 180 degrees? So what do we call an arc whose measure is exactly 180 degrees? Ooh, this is a good question. So we're told that this SVU, that V is in the middle of the name of the arc, so it tells you what direction to go. So it starts at S, passes through a point V, and then ends at U. And this guy is measured 138 degrees. And we are asked about TSU. So we want to know this angle. So I'm still waiting for a comment on what do you call an arc whose measure is exactly 180 degrees. You all know it. I know you all know it. So to complete this guy, this point S is on the circle. Just how with our inscribed, it is a semicircle. Max, you get a ticket. Thank you, Max. Yes, you get a ticket. Remind me when we get back to school. So a semicircle is an arc that is 180 degrees. So now with this angle TSU, the vertex of this angle is on the circle. Just how with an inscribed angle, the vertex is on the circle. So with an inscribed angle, the vertex is on the circle. The angle is half the intercepted arc. So the same thing happens with a tangent chord angle here. The vertex is on the circle, so the measure of the angle will be half the intercepted arc. So you probably know what question's coming up if anybody wants to earn a ticket and get it quickly. This major arc from S all the way around to U, now we should know the measure of this arc. The minor arc S through V to U, so SVU, was 138 degrees. So we should be able to come up with this guy, and I'm guessing there's people typing right now. I gotta think there's people typing in there. But we do know that the entire circle is gonna add up to 360 degrees. Our minor arc was 138 degrees. So what does that leave me with here? 222, did I do that right? I think so. Yes, Max, thank you, 222. I think I got a little bit of a delay with the comments here. So that means now that angle that intercepts this 222 degree arc has to be half. And this angle ends up being 111 degrees. Oh yeah, cool. Caleb, Blake, I see you guys got it. Ticket, ticket, ticket. All right, let's move on to the last guy from 12.3. Oh, okay. So check it out. We wanted to find the measure of this angle C right here. Well, if we look at C, it's an inscribed angle. We weren't told what this arc ADB is. However, we know that segment AB is a diameter. Thus, BDA, this arc, has to be your semicircle, has to be 180 degrees, and therefore C is a right angle. Okay, so C is a right angle. Now, thanks for all the comments. I appreciate you. Keep commenting. So keep those up. I love seeing those. I miss all you guys. Now, one more thing in section 12.3 that it talked about is I'm going to try and be less distorted here because my board's at a bit of an angle, is what happens now if we have some sort of quadrilateral, just some weird quadrilateral inscribed in a circle. So if you have a quadrilateral inscribed in a circle, we can think for these opposite angles, they intercept opposite arcs. Oh, okay. So these are inscribed angles. So Max says, can we always conclude that an inscribed angle in a semicircle is 90 degrees? Absolutely, Max. Good, 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 good. We can always conclude that. So that was Max's statement that said, can we always conclude that an inscribed angle in a semicircle is 90 degrees? And that is true. Always, always. So now if we think about this, the entire circle is made up of those two intercepted arcs, those two opposite intercepted arcs. Your entire circle measures 360 degrees. So that means that these two inscribed angles have to add up to half of that 360 degrees. Okay, so they're going to add up to 180. So that was the other thing that was talked about in 12.3, is that opposite angles in an inscribed quadrilateral are supplementary. Opposite angles of an inscribed quadrilateral are supplementary. Because these two now are half, they add up to half of the entire circle. So those two angles would have to add up to 180 degrees. Okay, cool, cool, cool. So there were some other questions that came about the homework check that's due, at midnight tonight. And so I'll address those guys. One of which was number 10. Now, for the homework check that's tonight, everybody gets different problems, but they're all kind of similar problems. And one of them in particular had an angle like this, and we were told that the angle is 55 degrees and asked for the measure of this arc. Oh, okay. So what we just kind of talked about was that anytime the vertex of this angle is on the circle itself, the measure of the inscribed angle would be half of the intercepted arc. Oh, so if the measure of the angle is half of the arc is going to be twice the angle. And sure, this guy would be 110 degrees. Okay, so that was one of them. Matt Cole, yes, you got it. I'll give you a ticket, Matt, when we get back to school. All right. There was another one that came up on the homework that's due at midnight tonight that had to do with, oh yeah, Billy, Max, ticket. It was something along these lines. Give me a second to do my best to draw it. We had a tangent segment like this. And we know that a radius, this is the center of the circle, pardon me if it's off a little bit. We know that the radius intersects the tangent at a right angle. And we didn't know the radius of the circle. So it was just called x. This tangent length was 16, and this length outside the circle was called 11. And so when we had this guy, sure, we have a right angle or a right triangle. So whenever we're talking side lengths of right triangles, hey, we're still thinking Pythagorean theorem. So we could set up a Pythagorean theorem equation for this particular right triangle. In this case, we'd have x squared plus 16 squared is equal to x plus 11 squared. Okay. Now, after this comes the most important mathematical concept to remember for the rest of your life ever. When we square this binomial, never, ever, ever will it just be x squared plus 11 squared. It will not be x squared plus 11 squared. We must FOIL that, double distribute, however you think of it. And we end up with x squared plus 22x plus 121. After you get it to this point, I'll let you finish it because it's a homework problem, right? I'll let you finish this, but you know those x's are going to cancel out, and then you have a single equation of one variable. Okay? So those were the questions that came up. FOIL, nice, Max, I love it. Those were the questions that came up on the Google Classroom question that we posted. So thank you for mentioning all those. It really helps lead these videos. And the other things that kind of came up were about properties and definitions and things like that. So real quick, if we have a segment whose endpoints are on the circle, that's called a chord. The properties we went over with chords before were that if a radius is perpendicular to the chord, that radius bisects the chord. And the converse of that is also true. So if we have a radius that bisects a chord, we know that radius is perpendicular to the chord. Okay? We had our tangent lines. So our tangent lines just touch the circle at exactly 1 point. Oh, I'm having technical difficulties here. They only touch the circle at 1 point. There we go. Sorry about that. And the radius will be perpendicular to the tangent. Okay. Now, a common misconception about tangents. I want to make sure we mention that. A common misconception about tangents is that something like this would be tangent, and that is not a tangent line, okay? Because if we extended this line, we would touch the circle more than once. So just because you have a segment that only touches the circle once, it's not necessarily a tangent line. It must maintain this property of the radius being perpendicular to it. So that line that passes through the circle more than once is what's called a secant line. Okay. And so for tomorrow, so for Wednesday and for Thursday, we're asking that everybody tries a GeoGebra activity. This GeoGebra activity will be very similar to the previous one we did when we came up with different properties. We're going to ask you to investigate, chords, tangents, and secants, and maybe like a secant angle, and compare the lengths of those as well as the angle measurements. Okay, gonna kind of leave it in a little bit of mystery right now because I think it's much better for you to try to figure it out for yourself on GeoGebra. So tomorrow the GeoGebra activity it's already posted. You can get it started, and we will post a video about like the tangent stuff, number one, that if you're struggling, you could refer to that video to kind of help you out, and maybe that would help you with the rest of them. We are at our time right now, trying to keep these to 15 minutes a day, so we don't get so we don't take up too much of your time. If there's any last questions, you can throw them in the chat right now. As far as the rest of the week goes, keep in mind we have the Pearson homework assignment that's due tonight. Then tomorrow and Thursday, you'll be working on that GeoGebra activity, that investigative activity. So try to get that guy accomplished. And then Friday, there's just something that will put it all together. Okay, that's the idea that we're going with for the rest of this week. I miss you all. Hope you're all doing well. Hope everybody is healthy. I don't see any last questions, so we will be signing off. All right. Bye, everybody. I will be back on Thursday. Mrs. Onemaker will be back tomorrow. All right. Adios. Stay healthy.